G'day crew. I had intended to finish the 2D sonar and start on the down vision in this episode, but I'm editing under very primitive conditions, so I'm going to make it a short video and just finish up what I wanted to say about the 2D sonar. I'm going to start off with a few real-life clips from my sonar screens. This clip illustrates what I've been saying about fish detection and sonar beam width. The 3D view transducer has a 120 degree beam width and it has picked up some fish on the bottom just to port of the boat. The low frequency transducer has a beam width of 22 degrees at the frequency I'm currently running, and it also shows at least some fish at the same position, although we don't know from that screen whether they're to the left or right of the boat or straight underneath us. The high frequency transducer has a beam width of 7 degrees at the current frequency, and it has picked up a few fish off the edge of the school. I have the 3D view configured to only show the strongest returns from fish, so it's likely that the school is larger than it shows on the screen, particularly if it's less dense towards the edges or if there are more smaller fish towards the edges. The point here is that had I been using only the high frequency narrow beam setting and been a metre or two further to starboard, I would not have seen the fish at all. As it is, had I only had that high frequency screen to look at, I probably would have ignored the show anyway, without the information from the other displays. This is why I run multiple sonars at once, to try and get the best possible information about what's going on below the boat. In this clip, the 2D sonar shows me that the depth is changing as I move forward, but the 3D view shows me that it also gets deeper to port as well as getting deeper ahead. Without the 3D view, I would have to rely on my chart plotter and reading the contour lines there to see that the bottom is sloping off to port as well. That's not too hard, it can be done. In fact, that's the way I did it until I got my first sounder that allowed me to view things in 3D, and that was a few years back. Now that I've had experience with both systems, I can definitely say that the 3D view is undoubtedly the best option. In this clip, I've managed to get my sabiki jig into the beam of the low frequency transducer and more or less into the beam of the high frequency transducer as well. I had to drop the line down very close to the back corner of the boat nearest the transducer in order for the sinker to show in both displays. Now, dropping a jig down beside the boat is not a bad way to gain an appreciation of just how close to the transducer something has to be in order for it to show up on the screens. I turned the gain up on the high frequency side just to make sure that I was going to be able to pick up the sinker if it was in the beam. You might notice that I turned it up just a bit too far, but you can see the hooks on this sabiki line from time to time as well. I undoubtedly overdid the gain in this instance, but you can see what effect the gain has. It puts a lot of noise into the view, but it also picks out some smaller objects that you wouldn't normally see, and that's generally not what you want anyway. I like to have a little bit of noise in the view, but not too much. These next two clips show some structure at Harry Atkinson's reef on the 2D and the 3D screens. Each clip is a pass over the same structure from a different direction. And I'll mention that in this case the gain on the low frequency side is set too high. It's probably too high to be able to see any fish returns that are holding near the structure. I had been playing with it for another reason and I neglected to reset it. I will draw your attention to the way that the red line thickens in the 2D returns as the structure comes into the beam. I've talked about the reasons behind this in previous videos, but this is a real-world example. I'll put some links to my previous videos in the video description below and also in the top pinned comment. And this is a good clip to illustrate just how much better the high frequency signal is at target separation when compared to the low frequency returns. Looking at these images, you'll see that the low frequency side shows more of the school than the high frequency side, but the high frequency side does a much better job of showing the individual fish when they're swimming close together. Now, how useful it is to see individual fish as opposed to a school of fish is something you have to decide for yourself. In this clip, you can see we're over some very uneven bottom, this time near the Rouse knob. And at this point, you can clearly see that there's a bottom shadow. I'll explain that. This occurs when we have a sharp drop to another level, or an overhanging rock perhaps. I'll try and illustrate that with a torch beam shortly, which might make it a little bit clearer what's happening here. This final clip is from Hutchinson's Shoal. It wasn't all that calm on this particular day, and the boat was rolling quite a bit when I captured this, so that's why the images aren't quite as good as normal. Even with the Furuno SCX-20 satellite compass, completely stabilising the image in these conditions is not possible. However, the image is far, far better than you could possibly get without the stabilisation provided by the SCX-20. The point of showing this clip is that while we can see the depth changing in the 2D view, it is only the 3D view that truly lets us see the bottom structure that we're moving across. In this sort of underwater terrain, even the contour lines do not fully convey the picture. No doubt you can find fish and structure with only a 2D sounder. People have been doing it for years. I did it for many years. But having that 3D view just makes it so much quicker and easier. So just to start the explanation here, I've got a tablet, a phone and a case just representing some structure on the bottom of the ocean floor. The torch here is representing the 2D sonar beam. So as the boat comes along, it sees this structure and it's giving the depth from the reflection of the sonar back to the transducer, but it's reading this depth, and this depth. So all three of these depths are being returned to the transducer, and that's the thickness of the red line. If we're over here, and we've just got this one and this one, it's only returning two depths, and we get a much thinner red line. But when we're over here, we've got a big difference in the depth, so we get a much thicker red line. I've tried to explain that in the previous videos, and I hope this makes it a little bit clear for anyone who's still struggling a little bit with the concept. And as we come over here, we have 1, 2, 3, 4 different depths being returned to the transducer. And not only does that make a thicker red line, but because we've got such a sharp drop-off between the depths, we will see sort of multiple, well, not multiple bottoms as you see when you increase the range on your transducer to see whether the bottom's hard or soft. But we'll see sort of multiple shadows on the bottom, and that shows that we've got two different depths and a really sharp drop between them. I'll show you some real live snapshots from the sonar screen, and hopefully that'll then make sense just exactly what I mean by the multiple shadows on the bottom. Thanks for taking the time to watch this video. If you found it useful and you want to see the rest of the sonar series, particularly the one on down imaging coming up next, or some of my other videos, please like and subscribe. Don't forget to hit that bell icon to be notified when I upload another video. Until next time, good fishing.